gentlemen. Thank you very much for giving me voice. Today, I'll be talking about biogas plant and this day would be work published in recent in chapter in a conference 2024. It's work by Chalakli Abuza and Olgur Elizarich from Hamdard University. And it's entitled Plasma Enhanced Microalgae Cultivation, a Sustainable Approach for Biofuel and Biomass Production. Plasma supported by chemical reactions have emerged as a promising environmentally friendly approach for synthesizing microalgae-based biofuels. Microalgae as a single cell organism possess the unique capability of efficiently converting sunlight into organic matter for photosynthesis, positioning with them as potential energy sources for biofuel and biomass production. However, traditional microalgae cultivations method encounters challenges concerning environmental and economic sustainability, primarily due to the high water and fertilizer consumption. In this context, plasma technology has emerged as a powerful tool supported by chemical reactions and optimizing microalgae cultivation processes, offering a greener and more sustainable alternative for mass and biofuel production. The contemporary energy paradigm is a crucial inflection necessitating a physical shift away evidence field that the aim is to reduce the global warming, which elevated per 5 year 1.2 degrees to 0 degrees, 0 to only 0 is the aim to 2030. The microalgae represented a heterogeneous plasma-genius photosynthesis entities and plasma applications conversion physics is field the electronics to medical sterilization, and plasma can be also decomposed. Lipid is prodigious lipid productivity from microalgae strains that could be to oil. The microalgae with the promising energy application still had a scale up for research environmentals. This stands to sharp contrast to stellar corn, which demands only 5 gallons on water, while tunnel wind, while high water point is here show the algas as 350 gallons for water for a liter of biofuel. Plasma technology is zeroed on plasma technology. Emerging evidence points in the transformative effects of plasma treatments in bolstering microalgae growth rates, amplifying liquid yields. The second endeavors amalgamate is to be present, understanding the plasma facilitating microalgae cultivation. Research terms were plasma enhanced microalgae cultivation fuels. This chapter focused on articles that specifically addressed the use of plasma technology in microalgae cultivation and were published in English. Papers not centered on microalgae cultivation or lacking significant information on plasma application were excluded. Relevant details, such as the author's publication, microalgae species studies, plasma generation methods, and main findings were extracted from the selected articles. Reliability of the included articles was gauged based on the experimental design, statistical analysis, and the robustness of the peer review process. The collected data were then processed to offer us insight into potential and beneficial plasma-supported reactions in macroalgae biofuel production. This fourth matter study, plasma often colloquially study, molecular level plasma emerges when gas undergoes ionization, a process often investigated as thermal excitation of electromagnetic fields. When a gas is subjected to a sufficiently high energy, its atoms or molecules begin to dissociate, liberating electrons from the orbits. This act of ionization results of coexistence of cations as positively charged ions. And these dislodged electrons are quasi-neutral state, wherein the number of positive and negative charges are almost equal. This dynamic concoction of charged particles, neutral species, and ensuring electric fields is what we use in the stars celestial phenomena. Is an alternative to virtualization method. Inactivates macronism. The active pivotal species can influence the potential tool, facilitating wound healing in medical treatment. This plasma produces this vast array of reactive species and capacity reactive oxygen species and reactive nitrogen species. Such species has been subject to vast research, especially in biology and medicine, as mediators of cellular signaling and potential agents of cellular damage at elevated node levels. The reactive species produced by plasma can modulate enzyme activities. This can be crucial in the control of various biochemical pathways, especially in the industrial biotechnology applications. And a class of waste products, reactive species can interact with proteins and nucleic acids. Plasma-induced reactive species can initiate lipid peroxidation processes, which depends on the context, whereas plasma. Experimental approach, especially in Chlorella vulgaris and chloroplasm, are to be sourced and establish algal repositories. Maintaining the integrity of these structures necessitates standardized environment. Ambient conditions are modulated to ensure that the temperature of 25 degrees. To optimize growth condition, aeration is facilitated using air and meticulously purified through filtration. This envisaged system harnesses the capabilities of dielectric barrier discharge to generate plasma. Intrinsic to the apparatus is a structural design featuring the electrodes aligned in the model parallel with isolated substrate acting as an intermediary. Nuances of plasma dynamics within the setup are contingent on an alternative current high voltage source. The architecture offers the flexibility of tweak the frequency of voltage, thus facilitating gamut plasma conditions tailored to the requirements. Anticipating a broad spectrum to dispose V-bipolar spec samples are subjected to plasma under diverse settings. In the aftermath, the exposure rigorous evaluation of initiated target key metrics. Ensuring inter-realm fatty acid these pigments, the dynamic specific roles of chlorophyll A, B, are associated with post-extraction acetone milieu with subsequent subspectral assessment shedding light of the concentration. The utility of plasma in macroalgae biotechnology application has been accentuated through the advent of a plasma-activated water. Subjecting water to non-thermal plasma enters with an elevated concentration. Introducing such pore to macroalgae endangers. This augmentation is not solely confined to growth kinetics. The heightened lipid biosynthesis is cardinal for biofuel production as it directly corresponds to enriched biofuel fuels. As empirical evidence accumulates, it becomes that plasma-augmented protocols might transition from experimental novelties. The ramification of this would inevitably set the stage for more resource-efficient environmentally bioenergy paradigm. Plasma activated enriched with reactive species has increased permeability of new microalgae cell membranes. The exposure of macroalgae to plasma-generated reactive species can stimulate the cellular metabolism and division. Activating oxygen and nitrogen species at control concentration can activate specific signaling pathway. The hormetic response, where low stress enhances the organism's resilience, equips the microalgae with heightened ability to resist adverse environmental conditions such as fluctuating pH, salinity changes, or nutrient scarcity. Plasma enhanced microalgae cultivation with its innovative mechanism brings forth a multitude advantage on accumulation per biomass. The water conservation is important to lower water needs and use the wastewater as source as the best. That will reduce the usage and use the utilization. Nutrient efficiency, phosphorus, and nitrogen has been linked to harmful ecological eutrophication in aquatic plasma. Plasma enhanced cultivation can enhance nutrient uptake efficiency, potentially reduces the needs of exogenous inputs. Carbon footprint reduction is important because it takes much carbon dioxide capture due to an overcome. The biopreservation many agriculture don't necessitate large tracts of arable land. By reducing pressure to convert forests and territorial habitats into agricultural lands, plasma enhanced microalgae cultivation can indirectly contribute to preserve biodiversity. Microthermal can be controlled environments, mitigating the risk of invasive species disrupting local ecosystem. Microalgae derived products research can be practical, elevated biofuel production, integration paradigms, by photobioreactor with solar energy, and waste heat utilization. These are environmental subtraction and five conclusion. We conclude this course before the consolidated understanding that insagreement the exploration has organically led to a just application of plasma physics with biochemical processes, while conventional microalgae cultivation methods have the merits incorporating plasma intervention presence in enhanced yield. It's merely quantitative but qualitative, thus for facilitating nuanced chlorella fungalis and spirulina. So that's all what I wanted to say. Thank you very much for listening to me.